Hello student, I am Tanmoy Majumder. In this video, I will discuss the main properties of linear regression equations and I will solve some mathematical problem of regression analysis. So student, I have told you regression analysis is a set of statistical processes for estimating the relationship between the dependent variable, which is often called outcome variable, and one or more independent variables, which is often called the predictors. So today we will just discuss the simple linear regression equations or the simple linear regression where we will get only two variable. One is dependent variable, another is independent variable. So here we will just consider two variable. Suppose in this regard I just give one example. Suppose variable x and variable y. Say suppose x variables is actually denoting the hours of study and y variable is denoting the exam results. In other case, say suppose the x variable is denoting advertising or y variables is denoting the sales. So by regression analysis, we will predict the average value of one variable for a specified value of other variable. And that estimation is done by means of suitable equations derived on the basis of available bivariate data. Bivariate data means there are two variable or two kind of data. One is x, another is y, we can assume. So when we should discuss the properties of linear regression, we should remember there are two linear regression equation. One is regression equation of y on x, another is regression equation of x on y. And these two equation, most importantly, you have to remember when you will solve the mathematical problem of linear regression analysis. So the first linear regression equation is the regression equation of y on x is y minus y bar equal to b lower suffix yx into x minus x bar, where byx is the regression coefficient of y on x equal to rxy into sigma y divided by sigma x. You know rxy is the correlation coefficient of x and y. So in the next line we have written covariant of xy divided by sigma x into sigma y. You know the formula of correlation coefficient, that is covariant of xy divided by sigma x and sigma y, that I have written into sigma y by sigma x. In the next line, covariant of xy divided by sigma x square. As sigma y and sigma y will be cancelled, so we will get covariant of xy divided by sigma x square. So after derivation, finally we can write byx equal to n into summation xy minus summation x into summation y divided by n into summation x square minus summation x whole square. So that derivation part I have shown in just my previous video. Similarly, the regression equation of x on y is x minus x bar equal to bxy into y minus y bar. And after derivations and simplifications, we will get bxy equal to n into summation xy minus summation x into summation y divided by n into summation y square minus summation y whole square. So student, here you should remember one thing. When we will say the regression equation of y on x, so definitely you should remember one thing. It will be y minus y bar, means y should come first. Then when we write byx, so obviously y should come first, then x and x minus x bar. So when regression equation of y on x you are making, at that time you should remember it should be byx, means y will come first then x. So when we will say the regression equation of x on y, so definitely you should write x minus x bar. As it is x on y, so you should write first x minus x bar. And when you will write b, means coefficient, regression coefficient, at that time you should write bxy because it is x on y. So you should write bxy and then you should write y minus y bar. And finally, when you will write the formula of byx or bxy, both the cases, the numerator portions will remain same. It will be n into summation xy minus summation x into summation y. But denominator portion is not same. But you can easily remember these things. Because when you will write byx, so x come later. So definitely the denominator portion will be n into summation x square minus summation x whole square. And when you will write bxy, So y come later, so definitely the denominator portion will be n into summation y square minus summation y whole square. Now the second properties of the linear regression is the product of the two regression coefficient is equal to the square of the correlation coefficient. It means the byx into bxy will be always rxy square. So we have done byx into bxy equal to rxy into sigma y by sigma x into rxy into sigma x by sigma y. So sigma x and sigma y will be cancelled and we will get rxy into rxy, that is rxy square. And finally we can write rxy equal to root over byx into bxy. So student, you should keep remember the two properties of the linear regressions. So in order to solve the mathematical problem, we should remember the two equations. One is the regression equation of y on x, another is regression equation of x on y. Second is you should remember the regression coefficient of y on x, that is byx, another is regression coefficient of x on y, that is bxy, and the product of the two regression coefficients, that is multiplication of byx and bxy. Now I will solve one math of regression analysis. So here the two variable has given x and y, and corresponding x value has given 1, 3, 4, 6, 8, 9, 11, 14, and y value is given 1, 2, 4, 4, 5, 7, 8, 9. Now what you will have to do, you will have to find out the correlation coefficient between x and y and determine the regression line of y on x and estimate the value of y when x is equal to 12. So here first you will have to calculate the correlation between x and y. Correlation coefficient between xy is denoting by rxy, and the formula is n into summation xy minus summation x into summation y divided by root over n into summation x square minus summation x whole square into n into summation y square minus summation y whole square. Now you will have to make a column to find out summation x, summation y, summation x square, summation y square, and summation x into y. Now I have written down all corresponding value of x and y which has given in the math. Now I have to make a column of x into y. I have just multiplied the corresponding value of x and y and get the all value of the corresponding column of xy. Now in the next step, I will have to make a two column, one is x square, another is y square. Now corresponding all value of x square I have written under x square column, and corresponding all value of y square I have written under y square column. Now I calculate summation x, summation y, summation xy, summation x square and summation y square. Now after getting all those value, I put those value in the formula of rxy. Now after calculating all those value, I got the value of rxy, that is 0.98. So I have got the first answer. The coefficient of linear correlation between x and y is 0.98. Now next I have to calculate the regression equation of y on x or regression line of y on x. The formula is y minus y bar equal to byx into x minus x bar. Now I have to calculate byx. The formula is n into summation xy minus summation x into summation y divided by n into summation x square minus summation x whole square. This formula is very much similar to the rxy. See the formula, rxy equal to n into summation xy minus summation x into summation y divided by root over n into summation x square minus summation x whole square into n into summation y square minus summation y whole square. Both the formula have the same numerator. Denominator, this portion is similar. So at the time of calculating rxy, we have got the value of numerator, that is 672, and the value of denominator portion, that is n into summation x square minus summation x whole square, is 1056. Now in the next step, I just put the value of numerator and denominator, that is 672 divided by 1056, and I have got the value of byx, that is 0.64. So in the next step, I will have to calculate the regression equation of y on x. So byx I have got, but I will have to calculate the value of x bar and y bar. At the time of calculating rxy, I have got the value of summation x and summation y, and the total number of observations is 8 for both the variable x and y. So we can say n equal to 8. And we all know the formula of x bar, that is summation x by n and summation y by n. So we have got summation x by n equal to 7 and summation y by n equal to 5, means x bar equal to 7 and y bar equal to 5. Now you will have to make the regression equation or regression line of y on x, that is y minus y bar equal to byx into x minus x bar. So you have got the value of y bar, so y minus 5, byx is equal to 0.64, x minus x bar is 7. And finally, after calculating, you have got the regression equation, that is y equal to 0.64, x minus 0.52. So you have got your second answer, that is regression equation of y on x. And finally, you will have to estimate the value of y when x equal to 12. So you just put the value of x in the regression equation of y on x and you will get the value of y. Finally, I have got the third answer of the given math, that is y equal to 8.2. So I hope this math is clear to everyone. So that's it. Thank you.